children. In today's class, we are going to learn about probability density function, abbreviated as PDF. A non-negative real valued function f of x. Something like this way, which is continuous, no break at all in between. If for each possible outcome x, where is x? X is inside the closed interval AB. Call it as AB. Where is x? X is here. So this area between A and B under the curve we call probability of A less than or equal to x less than or equal to B. How to find it out? It is defined as integral A to B f of x dx. What are the properties of probability density function? As I see from the diagram, f of x should be positive always. So f of x is greater than or equal to 0 for every x, and from minus infinity to plus infinity, integral f of x dx equals to 1. So every problem, when they mention it as a PDF, remember you can use this property. Minus infinity to infinity, integral f of x dx equals to 1. If I need to find out probability at a point x is equal to a, my answer is 0. Remember, in the previous exercises where we learnt probability mass function PMF, that is defined only at x is equal to a. It is not defined in every point. It is a discrete function. So it is defined at x is equal to a, at x is equal to b, and so on. Whereas continuous distribution, where it goes on and on like this, no break at all, P of x is equal to a is 0, because I write a to a whenever starting and ending is same in the integral. My answer is 0. So, using this idea and this idea, whether my question is this way or this way or this way or this way, my answer is same. Notice, in probability mass function, if I have this, I will not include a and b, only the values between a and b. Here, I will include a and between a and b. Here, I will include b and the values between a and b. Here, I include a and b and all the values between a and b. But in a continuous distribution, all the four, I understand integral a to b only. So, all are equal. So, for all the cases, my answer is integral a to b f of x dx only. No answer differs. According to inequality, we don't get different answers, but all are equal. A very important objective type question to remember. Now, as we did cumulative distribution function CDF in probability mass function, here also we call it as capital F of x. What is the definition we learnt? Probability of x less than or equal to x. Remember the word CDF tells me probability below that value. It is the same idea here. We have the same properties, only the formula is different. There, below x, I will add all the probabilities. Here, below x, I will integrate the function. So, what is capital F of x? Integral minus infinity to x, f of u du, What is u? U is between minus infinity to plus infinity. As we do exercise, we will learn better. This idea, a very important concept, that which connects PDF and CDF. If I need small f of x, capital F, I have to differentiate with respect to x. So remember the great formula, small f of x is derivative of capital F of x. Capital F of x is integral of small f of, instead of x, because it might confuse, we are having u du. Or in other words, I can say small f integral will give me capital F. Capital F derivative will give me small f of x. Let us continue with the exercise. Exercise 11.3, question number 1, PDF of x is f of x equals kx e power minus 2x for x greater than 0 and 0 for x less than or equal to 0. Find k. Given the word PDF of x, let me remember the property f is a PDF if integral minus infinity to infinity f of x dx equals to 1 and f of x is always greater than or equal to 0. This question is defined for x greater than 0. All other places it is 0. So minus infinity to 0. Let me split as minus infinity to 0 plus 0 to infinity. My question is from 0 only. Other places it is 0. So minus infinity to infinity we split into two parts. Minus infinity to infinity I use like this. Minus infinity to 0, 0 to infinity. Minus infinity to 0 tells me before 0, that is below 0. Below 0 the function is 0. Integrate it. Plus above 0 given k x e power minus 2x. Remember to put dx. F of x dx equals to 1. This is 0. Ignore that. Whenever my question is from 0 to infinity, I have some x powers and e power negative x. I can use gamma integral. My answer turns out with a simple formula n factorial by a power n plus 1. So we use gamma integral. When I use, I must compare and write what is a and what is n. Compare this and this. X power n. Here I have x power 1. So n is equal to 1. What is a? E power minus ax. E power minus 2x. As I compare e minus x, okay. Then what is a? A is 2. So I know what is a and what is n. Let me apply in the formula. So I get k is a coefficient like, keep it out of integral. Integral 0 to infinity. X power 1 e power minus 2x dx equals to 1. K into x power 1 e power minus 2x dx. I can apply the formula n factorial. 1 factorial by a power n plus 1. 2 power 1 plus 1 equals to 1. Let us remember 1 factorial is 1 divided by 1 plus 1 is 2. 2 square is 4, that is equal to 1 tells me k is 4. The question is to find k and we have found out k. Question number 2. Given the probability density function of x as follows. Find P of 0.2 less than or equal to x less than 0.6, P of 1.2 less than or equal to x less than 1.8, P of 0.5 less than or equal to x less than 1.5. However, the inequality comes. Let us remember the formula. Between A to B, the probability is integral A to B f of x dx. Here, I want probability between 0.2 to 0.6. Check in the formula. Where is 0.2 falling? 0.2 is here. 0.6. 0.6 is also here. So, according to the limits, substitute f of x. So, the formula says from 0.2 to 0.6, integrate f of x from 0.2 to 0.6, which is inside this interval. F of x is x dx. As I integrate, let me remember the formula. Integral x power n dx is x power n plus 1 by n plus 1. Here it is x power 1. So I will write x power 1 plus 1 by 1 plus 1 between the limits 0.2 to 0.6. Or it is x square by 2 between 0.2 to 0.6. Wherever x is coming, put upper limit. This we call upper limit and this we call lower limit. So, 0.6 the whole square by 2 minus 0.2 the whole square by 2. 0.36 by 2 minus 0.04 by 2, that is 0.18 minus 0.02, and we get 0.16. The second subdivision, P of 1.2 less than or equal to x less than 1.8. Integral between 1.2 to 1.8. Where is it coming actually? 1.2 will be in this interval 1 to 2. 1.8 is also inside this interval. So what is f of x here? I am having 2 minus x. As I integrate 2 minus x, constant 2 will become into x. Remember, in integration, 2 will become 2x. 3 will become 3x, 4 will become 4x, and so on, as I have dx here. Minus, for x, we apply the same formula, x square by 2, between the limits 1.2 to 1.8. Just substitute. Wherever x is coming, 1.8. Minus, wherever x is coming, 1.2. 2 into 1.2 minus 1.2 square by 2. Simplifying, probability of 1.2 less than or equal to x less than 1.8 is 3.6 minus 3.24 by 2 minus 2.4 minus 1.44 by 2. Simplifying which, we get 0.30. Third subdivision, 0.5 to 1.5. 0.5 to 1.5 f of x dx. How to find it? 0.5 is in first interval, whereas 1.5 is in second interval, which is the connecting number 1. So, how will I split this interval? 0.5 to 1 plus 1 to 1.5. We have to write f of x carefully. Question is from 0.5 to 1.5. But we have the split in 1. So, 0.5 to 1.5 is 0.5 to 1, 1 to 1.5. 0.5 to 1, what is the function x? 1 to 1.5, what is the function 2 minus x? As we integrate, x becomes x squared by 2 between the limit 0.5 to 1 plus 2 becomes 2x, x becomes x squared by 2 between 1 to 1.5. As we simplify, it is x squared 1 square by 2 minus 0.5 square by 2 upper limit minus lower limit plus 2 into 1.5 minus 1.5 square by 2 upper limit minus lower limit is 1. 2 into 1 minus 1 square by 2. As we simplify, we get 1 by 2 minus 0.25 by 2 plus 3 minus 2.25 by 2 minus into 2 minus into minus plus 1 by 2. Since 2 is the LCM, we have 1 minus 0.25 plus 2 3s are 6 minus 2.25, 2 2s are 4 plus 1. Simplifying which, we get all the positive together 8, negative together 6.50. 8 minus 6.50 is 1.50 by 2. That leads to 0.75. Question number 3. Suppose that the amount of milk sold daily at a milk booth is distributed with a minimum of 200 and a maximum of 600 liters with a probability density function given. Find K, the distribution function, and probability of sales between 300 and 500. Given f of x is a PDF, we know f of x is greater than or equal to 0 and integral minus infinity to infinity f of x dx equals to 1. Here, the question is from 200 to 600 only. The remaining places it is 0. As I integrate 0, 0 only will come. So minus infinity to infinity redefined as integral 200 to 600 f of x dx equal to 1. Here 200 to 600 f of x is given as k dx equal to 1. Constant, when I integrate, it becomes k into x. Whenever dx is coming, k will become kx. Between the limit 200 to 600, that is 1. Put upper limit k into 600 minus k into 200 is 1 or 400k is 1. That implies k value is 1 by 400. The second question, distribution function. What is the formula for distribution function? It is capital F of x equals to probability of x less than or equal to x or minus infinity to x f of u du. In this question, x can be below 200. X can be between 200 and 600. X can be above 600. So we have three ideas. X below 200, x between 200 and 600 and x greater than 600. How to write capital F of x? Integral minus infinity to x. Below 200, the function is 0. So I have minus infinity to x, 0 dx, and my answer is 0. Distribution function f of x can also be written as integral minus infinity to x f of x dx. The second interval x is in 200 to 600. How will I write capital F of x? It is minus infinity to x, f of x dx. Minus infinity to 200 because now x is from 200. So minus infinity to 200 plus 200 to x. Minus infinity to 200, the function is 0. And 200 to x, above 200, the function is k. What is k value? 1 by 400 into dx. Integral 0 is 0, omit this. 1 by 400, integral dx, we will simply write x. Remember, integral of a constant is constant into x. Between the limits 200 to x. How will I simplify? F of x equals 1 by 400 into upper limit minus lower limit. Upper limit x, lower limit 200. Or if I multiply in x by 400 minus 200 by 400, that is x by 400 minus 1 by 2. The next interval, x is greater than 600. Now what is f of x? The same idea. Integral minus infinity to x, f of x dx. How will I split it? Integral minus infinity to 200 plus 200 to 600 and x is above 600. 600 to x. Minus infinity to x is my general formula. Here, my question is split from 200 to 600. So, minus infinity to x. What is x? Value above 600. So, how will I write it? Minus infinity to 200, 200 to 600, 600 to x. Minus infinity to 200, function is 0. 200 to 600, the function is k. K value is 1 by 400 into dx. 600 to x, above 600 also 0. So, 0 when I integrate 0. So, omit this, omit this. 200 to 600. 1 by 400 dx only we did here. 200 to 600, k value 1 by 400. My answer is 1. So, this will give rise to 1. So, we have found out the distribution function for 3 different intervals. Below 200, between 200 and 600 and above 600. Let us tabulate the values. F of x equals to 0 when x is below 200. X by 400 minus 1 by 2 when x is between 200 and 600. 1 when x is more than 600. So, whenever we do distribution function, we have to write it when x belongs to the various intervals. The question is from 200 to 600. So, we need to split it. What happens when x is below 200? What happens when x is between 200 and 600? And what happens when x is above 600? So, below 200, the function is 0. If I integrate, it is 0. Between 200 and 600, I split it like this way. Minus infinity to 200, 200 to x. Let me say x is 220. So, x is between 200 and 600 tells me some example. X is 220. How will I write it? Minus infinity to 200, 200 to 220. Like that. Whenever x is between 200 and 600, minus infinity to 200, 200 to x. This is 0 obviously because below 200 function is 0. 200 to x, it is k. What is k? 1 by 400. So integrate it, apply the limits and simplify. This problem, upper limit is always x. So wherever x comes, put x itself. Lower limit changes, so write accordingly. When the third interval comes, that is x is more than 600, say 650. My formula is minus infinity to 650. How will I split it? Minus infinity to 200, 200 to 600, 600 to 650. So here x is between 600 and infinity. That is x is above 600. So whenever x is above 600, we split as 3. Minus infinity to 200, 200 to 600, 600 to x. It is obviously 0 in first and third interval because the function is defined only from 200 to 600. This answer, as we know from the first line, it is 1. 200 to 600 k dx is 1. K is 1 by 400 and so my answer is 1. Tabulating all the three, we have the distribution function. Third subdivision to find P of 300 less than or equal to x less than or equal to 500. Remember the formula P of x between a and b is capital F of upper limit minus capital F of lower limit. Let us recall f of x from the previous step. My question is between 300 and 500. It is f of 500 minus f of 300. 500 falls here. So let me substitute 500 by 400 minus 1 by 2 minus, where does 300 fall? In the three intervals, 300 also falls here. So I will substitute 300 by 400 minus 1 by 2. It is 5 by 4 minus 1 by 2 minus 3 by 4 minus into minus plus 1 by 2. 1 by 2 cancels. 4 is the LCM. 5 minus 3 and we get 2 by 4, that is 1 by 2. As the question is in statement, let us write the answer also as a statement. Probability that the daily sales will fall between 300 liters and 500 liters is 1 by 2.